Hello everyone, my name is Jingjing Tian. I'm a software engineer from data governance team at Confluent. In this video, I'll be giving you an overview of how Schema Linking works, which is now in preview as part of our stream governance offering, and how we can use either C Cloud CLI or REST API to interact with this feature. As this diagram shows, Schema linking is often used to keep schemas in sync between clusters. To understand how it works, we have to understand the concepts of context and exporter. In short, a schema context represents an independent scope within Schema Registry and can be used to create any number of separate sub-registries within one Schema Registry cluster. A schema exporter is a component that resides in Schema Registry and that can be used to do the actual work of exporting schemas from one Schema Registry cluster to another. When used within the same cluster, schema linking is often very useful for promoting schemas across different contexts. Say you have a test context, and you can promote your schemas from the test context to staging context, and further from staging to production. To get started, you first have to register your account at Confluent.cloud. In this video, I'll be using two Schema Registry clusters denoted as source and destination respectively. As a first step, let's first register some schemas in the source so they could be exported. And let's put them into subjects called foo and bar. Now we can confirm they have been created. Let's use REST API and CLI to create new exporters whose names end with API and CLI respectively, just to differentiate. We first start with REST API, and we need to pass a config file as a body to the post request. Here I show you the sample config file, in which we specify the name of the exporter. Though we use the full subject name, we can use wildcards to specify subjects with prefix or even the whole context to export. We also put the context type and name in the config. If the context type is auto, the context defaults to the source Schema Registry cluster ID, which applies in most cases. Finally, we put the endpoint and credentials to access the destination cluster. We use this config file to create our first exporter by posting to the exporter's endpoint. And it has been created. We can also use Confluent Cloud CLI to create the exporter, but in order to do so, you have to make sure you are using the latest version. Let's first make sure we are using the source environment. Creating an exporter with C Cloud CLI is very easy, and we are basically passing the same parameters that we did with REST API. Cool. The config file contains the endpoint and credentials needed to access the destination Schema Registry cluster, and here is a sample one. After we have created some schema exporters, it's time to see what we have now by getting the exporter's endpoint. Another way to list exporters is to use C Cloud CLI. And we can see we have created a total of 2 exporters at this time. Nice! Our exporters are successfully created. Let's try to get some information about the exporters. We can also do this with C Cloud CLI. We can get the dynamic status of the exporter by querying the status endpoint that shows the running state of the exporters. Here, running means that the exporter is now up and running and is capturing any newly created registered schemas in the source cluster. Let's do it with C Cloud CLI. Now that we know the exporters are running, we can check in the control center whether schemas have been exported successfully. Of course, we can also do this with CLI or REST API. Usually, the new subject names are prefixed with context name, which is surrounded by columns. In our case, the context name is exactly the same as what we provided during creation. We can also get exporter configurations only by using the config endpoint. And let's do this with C Cloud CLI. Apart from querying the information, we can use the APIs to manipulate the life cycle of the exporters. For example, we may want to pause the exporter with a put request to the pause endpoint. And let's pause the other exporter created by CLI. Sometimes you've changed your mind and want to use your exporter to migrate a new set of subjects from scratch, or you want to switch the context name. For this purpose, while the exporter is in paused state, we can reset the offset so that the exporter will start all over again. Let's also reset the exporter created with CLI. Now we use the update API to change either the information or configs of our exporters. The content of the file is very much like the one used during creation, but only contains the attributes you want to update. Say we want to export subjects called bar this time. Here is the sample config file. Let's do it again with C Cloud CLI by specifying the subjects to be bar. Let's see what has been changed. Pay attention to how the subjects have been updated and how the offset is reset. After making some changes, we can resume the exporter so that the exporter will be running again. Let's send a put request to the resume endpoint. Let's resume the other exporter as well. At this moment, we can go back to the UI to confirm that now both full and bar have been exported with our updated exporters. Because we are exporting the bar from scratch, the originally exported full subjects will not be impacted. That's why we are seeing 4 subjects here. At the end of the lifecycle, we can then delete the exporter as long as it's in paused state. We first send a put request to pause API, then a delete request. The same commands is available in the CLI. Finally, we can confirm that all exporters have been deleted with the help of either CLI or REST API. And nothing is here. I hope this video gives you a better start when you are trying to play with schema linking. Thanks for listening.